The infamous Quine-McCluskey method. A very long and drawn-out, tedious process in finding a minimum Boolean expression. But it's accurate, and it'll yield the same results that a K-map would. And to give you an idea of how tedious it is, I've actually already had to restart this video because I messed up on the last one. So let's see if I can get it right this time. To start off, we're given this function, this 4-variable function, in the summation of minterms. The first step in the Quine-McCluskey is to group these numbers in such a way using their binary equivalent. And what I mean by that is, if they have a single 1, they're going to get grouped together. If they have 2 1s, they're going to get grouped together. If they have 3, they're going to get grouped together. So to show you, we have the 1 here, which is 0, 0, 0, 1. Now looking at the 5, it would be 0, 1, 0, 1, and looking at the 7, it would be 0, 1, 1, 1. But looking at the 8, it would be 1, 0, 0, 0. So we can group that together with that. So that's 1, 0, 0, 0. And it's important to keep track of the numbers that you use. Now, since I've already solved most of this problem before, I already know that that's it for this group here. So I'm just going to put a little line to separate that from the others. The next group, we're looking for numbers that have 2 1s in their binary equivalent. To start, we've got the 5, which is 0, 1, 0, 1. The 7 is 3. The 10, we've got 8 and 2, so that goes here too. So 8, 0, okay. The 8 place and then the 2 place, yep. Okay, so, and the 11 is going to be 3. The 12, we're going to have an 8 and a 4. So we'll put that in there too. So 1, 1, 0, 0. Check that off. What else we got here? The 14 is going to be 3, and the 15 is going to be 4. So that's it for this group, so we'll mark that off too. And the reason I'm doing this is because we're going to be comparing this group here with this group down here individually, and you'll see what I mean in a minute. Next group, we're looking for numbers that have 3 1s in them. Of course, we already know that the 7 does. So we've got the 7, which is 0, 1, 1, 1. The 11, which is 1, 0, 1, 1. The 14, that's 1, 1, 1, 0. And the 15 is going to be in a group of its own. Okay. All right. On to the next step. Now, this is where people get confused, is how to group these two numbers in these two groups together. So I'm going to get another color here, and I'm going to show you exactly what I'm doing. So for starters, I know that we're going to start with this group and try to group it with the second. Okay, so we're going to group this group with this one at a time. Okay, the first ones that are going to go together are the 1 and the 5, and the reason is because they have one bit that's different. Now, if you compare the 1 with any other number in this group, compare it to the 10, and compare it to the 12, they all have more than one bit different, so they're not going to be grouped together. So let me get back to the regular color here. So for our first group, we're going to have the 1 and the 5. And the way that we write that, because this bit is where they are different, we're going to write it as 0 dash 0 1. We just put a dash where they have a different bit. Moving on, now that we've compared the 1 to this group, we're going to compare the 8 to this group here. Okay, so looking at this, we have 1 0 0 0. The 5, looking at the 10, those go together because this bit here is different. It's only one bit that's different. So we're going to have the 8 and the 10, and we write that as 1 0 dash 0. I'm going slow because I do not want to mess this up. Errors at this point in the problem will throw the entire problem off. Okay. And we should also be checking these as we go. Okay. What else can we compare the 8 to? Well, if we look at the 8 and the 12, 1 0 0 0 and 1 1 0 0, they only have one different bit on the second. Okay? So that one will look like this. The 8 and the 12, it's going to be 1 dash 0 0. Okay. And that finishes off that comparison of this group to this group. So next we're going to compare this group to this one, and then this one here to the 15. So far so good. I don't see any mistakes, so that's a good thing. One less thing. Alright. Comparing the 5 to the 7. They are also different by one bit. So we would have 0, 1, dash 1. And that's the 5 and the 7. Let's compare the 5 and the 11. Those are different by 2 bits. 3 actually. 1, 2, 3, yep. Let's compare the 5 to the 14. That's different by more than 1, so we can't use that. Moving on to the 10. Compare the 10 to the 7. That's different by more than 1. Compare the 10 to the 11. That looks like it's only different by 1 bit, the last one. So, 10 and 11. What am I doing? I can just undo that if I don't like it. 10 and the 11. 1 0 1 0 and 1 0 1 1. So we're going to have 1 0 1 and then the dash, because the last bit is different, so that's where the dash goes. And we can check that off. Now compare to the 10 to the 14. 1 1 0, 1 1 1 0 and 1 0 1 0. That's also different by only one bit. So 10 and 14, 1 dash 1 0. Now moving on to the 12, comparing the 12 to the 7, different by more than 1 bit. Comparing the 12 to the 11, different by more than 1 bit. Comparing the 12 to the 14. That works, only the third bit's different. So let's write 12 and 14. (11) dash 0. Okay. And that's it for that comparison. So I'll put a line here. Now we're going to compare the 7, 11, and 14 to 15. Now you'll notice right away that they are always different by 1 bit. So let's just write it out. It's a good habit. We don't have to, and you'll see why after you do this a couple times that you don't have to do this. You don't have to get every single one. Once you get them checked off, you're generally good. But it's just, you know, when you're beginning, this is the way you want to do it. Okay, so 0, 1, 1, 1. Compared to that, we have dash 1, 1, 1. And then we have 1 dash 1, 1. And then we have 1, 1, 1 dash. Okay. We're making progress. Alright, so for the last phase is to compare this group here with this group, and then this group here with the last. Now the way that we're going to do it's a little different than the last time. What we want to do is match up where the dashes are, and we also still only want it to be different by 1 bit maximum. So we're going to compare the 0-01, and this is where it starts to get tedious and where mistakes can be made if you're not very careful. One of the places at least. So if we look at this, we're going to look down at the ones that only have the dash in this spot, which is just the 10 and the 14. But comparing the two, you'll see that those are different by more than 1 bit. Actually, they're different by 3 bits. So those aren't going to work. And what that means is the 1 and the 5 are going to be taken by themselves. So I'm just going to circle that for now. I'm not a fan of shaky handwriting. Alright, moving on to the 8 and the 10. The only ones we can compare it to are the 5 and 7 and the 12 and 14. So let's look at the 5 and the 7. They are different by, I'm sorry, not the, the 5 and 7. They are different by 1 bit, 2 bits, and 3 bits, so that's not going to work. Now let's look down at the 12 and the 14. So comparing these two, you see that it's 10-0 and 11-0. So they're only different by this bit right here. Okay? So let me just get rid of that. Okay, so we have the 8 and the 10. This is our new group over here. And the 12 and the 14. And the way we write that is, where the bits are different, again we're going to put another dash. 1 dash, and then the original dash, and 0. Okay, so we've done that. We've done this one here, and we've done this one. Okay, on to the 8 and the 12. Comparing that with the second group, it only matches up, the dash only matches up with 1. And they are also different by 1 bit. Let me show you what I'm talking about here. They are different by this bit right here. So we would have 1 dash dash 0. So we have the 8 and the 12. And I said the 10 and the 14, right? Yeah. And we would have 1 dash dash 0. Now, you may have noticed we just got the same result, 1 dash dash 0. Now look at the numbers. And this is what I was talking about before. You'll see that you don't always have to include every single one, every group more than once. But as a beginner, it's a good idea, it's a good habit to just go through all of them, because it really doesn't take that much more effort. And it's good practice anyway. Okay, so that finishes off that group. Alright, moving on to the next. Comparing the 5 and the 7 with this group down here, 0, 1, dash 1. The dash does not line up with any of them. And yes, that means that this has to be taken by itself. And I'll explain what that means once we get to the final part of this method. Just put a little check mark there. We know that we have already dealt with that. So the 10 and 11, it only matches up with 1, and they are different by 1 bit. So that means we can take that. So our new result's going to be 1 dash 1 dash. Okay. Hope you're following along. I know that this can be confusing. So the 10 and the 11 match up with the 14 and 15. And we're going to have 1 dash 1 dash, right? Yep. Check that off. Now, you'll notice pretty much everything's checked off. But like I said, it's a good habit to continue going through. So let's look at 10 and 14. The dash matches up with the 11 and 15, and they are different by 1 bit. Okay. So we have the 10, 14, and the 11 and 15. And you might have already seen that it's going to give us the same results as before. And looking at the 12 and 14, nothing matches up. Okay, forgot to check one off here. Make sure that I do that. Okay, and this one here didn't get a check, so this one's going to also have to be taken by itself. Okay, on to the final phase. So here's where we're going to map out and find our final expression. Remembering what these represent, where this is W, X, Y, and Z here. And remembering that we took this, and these groups over here. Now we're going to take these and put these into a table. So it doesn't really matter where you start here. So we're just going to start with the 8, 10, 12, and 14. The 1 dash dash 0. W, X, Y, Z. This is not completely necessary here, but it's good to see what it represents. And you can see that this is actually, if I could stop writing messy, this is actually W, Z, naught. Looking at our next expression here, 1 dash 1 dash. 1 dash 1 dash. That's equal to W, Y. And you can see where I'm going with this. Looking at the 1 and the 5, we have 0 dash 0, 1. So W naught, Y naught, and Z. And I'm skipping because of these dashes here. It's the equivalent to a don't care if you're familiar with that term. Next, moving on to the 5 and the 7. 0, 1, dash 1. And I hope I'm not driving you nuts by going this slow, but I do not want to mess this up. And our final term, dash 1, 1, 1. The equivalent to X, Y, Z. Right? Yep. All right. Now, with this, there's even another step. It's like it never ends. And we're going to list out our minterms now. I'm just trying to figure out the spacing here. Will I have enough? 1, 5. No, I'm going to have to do one at a time, or one for each column. So, oops, that doesn't work. Switch back over to pen. So 1, we got the 5, 7, 8, 10. I like to have a space in between them, but I don't think I have enough room. I'll do it anyway. 1, 5, 7, 8, 10, 11, 12, 14, and 15. Okay, that'll look fine. You just have to keep them in line. All right. Now, looking at each of these expressions here, notice that this corresponds to 8, 10, 12, and 14. So we are going to put an x at 8, 10, 12, and 14. Okay? Notice that this corresponds with 10, 11, 14, 15. Usually I write the number right in front, but I don't have enough room to do this all on one page. And usually I'll take pages, several pages to do this so that I don't screw up. I definitely wouldn't recommend trying to do this on one page. This is kind of ridiculous. Okay, so, and this is a small problem. 1 dash 1 dash corresponds to 10, 11, 14, and 15. Okay? So 10, 11, 14, and 15. 0-01 here corresponds to 1 and 5. I'm going to write this in. Just write it underneath. That's what I'll do. So 8, 10, 12, 14, and then we have 10, 11, 14, and 15. Here we have 1 and 5. Here we have 5 and 7. And down here we have 7 and 15. Okay, so we did the 1 and 5. Now we're going to do 5 and 7 for this one here. 5 and 7. And then 7 and 15. 7 and then all the way down to 15. Now this particular step might take some trial and error. And one of the best ways to do it here is with a highlighter. Something like this. What you want to do is highlight as many x's as possible, but the rules are, for this expression here, we're highlighting it all the way across, and then we can only highlight down or up if we've crossed an x. For example, we crossed an x here, so we can go down here. We didn't cross an x here, so we can't highlight that. We crossed an x here, so we can highlight that. And then these ones down here remain as is. And we move on to the next expression in a different color if you choose. So the next best one, I mean, there's no other way to take this here, so we are going to have to use this expression here. Highlighting across and down. That's better. Whatever. For the next expression here, we can take those and then this one with it. And we're left with one more. And it's really your choice. And this is what I was saying. With the K-map, you'll get something similar, but it's just as efficient. So if you wanted to use, like, as, for example, as little NOT gates as possible, you would maybe just not use this expression because it has a NOT. So you would just use this. I just like to work top to bottom, so I'm going to highlight here, and you can come down. And then this expression down here is just not needed at all. Alright, I just had to clean up that mark. It was just bothering me. Okay, so now we can take our minimum expression, and this is all it is. excluding this last one, which we didn't use. You notice we don't have any, we didn't highlight anything there. We got all the x's covered without using that. So our new minimum expression is, and the answer to our problem is wz naught wy w naught y naught z w naught yz. And that right there is our answer. If you have any questions about this method, please feel free to ask. Just leave them in the comment section. If you find any mistakes, please let me know, and I will place any necessary notes or annotations in the video. And if you have any suggestions or for upcoming videos, please also leave that in the comment section. And thanks for watching. So I actually went through my video before I posted this, and I did end up finding a mistake. It's a small mistake, but it would probably irritate people. It irritated me a little bit, so I'm going to just correct that here. You'll notice that right here I put w naught y z when this is actually w naught x. There is no y and then z. So this actually should read x. Additionally, that would mean that my answer would be different. So the corrections are, this would be an x, and this would also be an x, and that is the correct answer. Now we can check our work that we did on the using the Quine-McCluskey method using a K-map, like I said. So we have our little K-map here. You may or may not be familiar with them or remember, but this is a refresher here, for me at least. This is the way we number it. We got the 4, 5. Okay. And can't forget the outside numbers here. 0, 0, 0, 1, 1, 1, 1, 0, and the same. I should probably do another video on K-maps. Yeah, I think that's what I'll do next. Alright. For our minterms, 1, 5, 7, 8. 10, 11, 12, 14, 15. Okay. Let's see what we have here. The best way to group this would be, well, we know we're going to have to take this alone. And that's going to be W naught X is changing, so we don't have that. And then Y naught z. Let's see what else we got. We're going to take this one here. So that's going to be w x changed, so that's not going to be there. Y changed, and then z not. What else we got? We can take these four. So that's w x changes, y, and z changes, so that's not there. And for the last term, we can take 2, but looking back on our expression that we got using the Quine-McCluskey, we got wy, we got this, we got the wz naught, we definitely got this, and then our last expression was w naught xz. So this would be the one here that we'd take w naught, and then that's not what I meant to write. W naught x, w naught x, y is not there, and then z. And that would be the last bit of our expression that we had. So we got the right answer using the Quine-McCluskey.